Okay, so in this video what we're going to do is define what a function is. And we know some things about graphing, and we know some things about lines and curves and things like that, but we don't quite know, or we have yet to define exactly what a function is. Okay, so this is the beginning of Unit 2. It's called Functions and Modeling. Our learning target for today is, and I know you can't see it written over there, but is to be able to define a function, hopefully that you can state the definition of a function, and that at the end of this class that you could use the vertical line test to figure out whether something is or is not a function. So functions come in two forms. One, you can see an equation. Those equations can be written as f of x equals, or they can be written as y equals. Either way is fine. This is not, even though this is called function notation, you can have functions that have a y equals. The definition for a function is right here. It is that for every input there is one and only one output. Things to remember is that input is our independent variable. That is your x. Output is your dependent variable. It's your y. Another way to state this is that for every x gives only one y. So if I put a 5 in a function, I don't get two options for y. Okay? A clarifying point is that you can have two or the same output for two different inputs. So if I put in, say, -5 to my function, maybe I get out 25. But if I put in +5 in my function, I get out 25 also. That output, that 25 being the same, that's okay. What's not okay is putting in a 5 and getting out either a -25 or a 25. That's how you kind of look at it in an equation sense of the word. If I show you a graph, what you need to know is that graphically we must always pass what's called the vertical line test. So our vertical line test just states that if at any point, okay, a vertical line will only touch your function once. So the vertical line test says any vertical line will pass through the function once. So let's kind of see what that looks like. Here we have the graph of a line, and we know that it does go on in both directions. Well, what the vertical line test says is I can put a vertical line there, and it touches only at one point. So far, it looks like a function. And I could put a vertical line here, and it touches at only one point. So it's a function. If I repeat this process an infinite amount of times, I am only going to get vertical lines that touch one time. This is what we call a linear, because it's a line, and a function, because it passes the vertical line test. Here we have something that forms a parabola. That parabola means that we have something quadratic. And the question is a parabola a function? Well, what you can determine is, what you can do is just draw some vertical lines. That vertical line touches once, that vertical line touches once, this vertical line would touch once, and that's it. There is no way, even if, because a parabola is going to keep getting wider and wider and wider, it's never going to curve back in on itself. No single vertical line will ever touch this twice, so I can come back through and say this is a quadratic function. Okay? Now, let's look at these two examples over here. Here I have what looks like a sideways parabola. We had a parabola here and we said that was a function. But watch what happens when I have the vertical line test. When I draw a vertical line here, it doesn't touch at all. So far we seem okay. If I draw one that just barely touches, it touches only one time. So maybe we're okay. But if I put a vertical line over here, I see that it touches once and twice, and you probably could tell that. But just one vertical line that touches at 2 points means this is not a function. So it is not a function because any vertical line over this way would always touch 2 times. If I look at my last one right here, what I'm going to see is that the same thing's going to happen. I'm going to have some places where vertical lines are going to touch 2 times. So circles and ovals are not what we call functions. Okay? So this is not a function because of that green vertical line touching twice. So to summarize quickly, what we have is functions and modeling. We have equations, and equations can always be graphed. We can always come up with some inputs and outputs by creating a table of values, such that this might be the equation of, say, y equals, looks like it's going over a little faster, so let's say 1/2 x, and the intercept might be 2 plus 2. That's a linear equation, which is a function because any vertical line would pass through the graph only once. Here we have a quadratic function. It might be f of x equals x squared. Actually, I'm going to write this in vertex form because it looks like it went to the right 2, so x minus 2 squared. And maybe down 2 also, so minus 2 again. This could be those functions. Whereas this function might be x equals y squared, and then moving the vertex up and over. And this would be kind of an x squared plus y squared. Those are not functions. These are functions. They can be written as equations. They can be graphed. I know that every x I put in will give me a distinct output, and that is, by definition, what a function is.